Hello, good afternoon everyone. Welcome to Sisyaclass. Welcome to yet another session in this week for 1:30 to 2:30. In today's session, I'm going to cater for grade 10 students, and the topic is very well versed with all of you who are going from grade 9 to 10. You all know about this topic. You have learned about this concept in grade 9 also. This is known as rational and irrational numbers. We'll be moving ahead building on the concept, and we'll be learning some new concepts which are related to grade 10 only. We'll be learning about advanced concepts of HCF and LCM as well. So without further ado, let me introduce myself. So my name is Shrikesh. I've completed my education from IIT Gandhinagar. I have more than 8 years of teaching experience in mathematics, and in these 8 years, I've taught more than 1 lakh students. A lot of students are studying in IITs and NITs. So that's about me. Let's start with this topic. I'll be telling you about HCF and LCM, and please stay tuned. There's a special reveal for all of you. So I'll be telling you about this special reveal, and if time permits, we'll also learn about irrational numbers. Otherwise, this special reveal would be enough for you, let me tell. So before we learn about HCF and LCM, there is a fundamental theorem of arithmetic which is very, very important for us to understand. And the fundamental theorem of arithmetic is related to composite and prime numbers. It states that any composite number, however big it may be, can be represented as a product of only prime numbers, and this representation is unique for each and every number. As it is written over here, you may take notes and screenshots as well. So every composite number is a number which has more than 2 factors, can be expressed as a product of only prime numbers. And this representation is unique. So this theorem has 2 parts to it. The first part is every composite number can be expressed as a product of prime numbers only. Second part is this representation is unique for that number only. For example, 24 can be written as 2 times 2 times 3, 2 times 3. This representation 2 cube into 3 is unique to 24. No other number can have its expansion to be 2 cube into 3. Makes sense? That is what this theorem also says. Same way, 100, 2 times 2 times 5 times 5, it's 2 square into 5 square. Again, this representation is unique to only 100. Now let's move ahead and let's build on this concept. Let's see one example. So this example here, the question says that can 4 to the power n end in 0? So 4 to the power n can be expressed in this way. All of you would know from law of exponents that we can write it using power law like this. 4 can be written as 2 squared to the power n. Now we can multiply these 2 powers, and I can write this as 2 to the power 2n. Everyone agrees with me? Now till here everyone is clear, but how to prove that, or how to find 4 to the power n ends in 0 or not? For this you need to understand one concept. Any number which ends in 0 will always have its one of the factors to be 10. You agree with me? For example, if I have 10, it always has 10, or let's say 20, it will always have 2 into 10. If it is 30, it's ending in 0, it will always have 10, its factors. 10 as one of the factors. And what is 10 made up of? 10 is made up of 1, 2 and 1, 5. 10 is written as 2 into 5. So this is some basic concept which we will be utilizing over here as well. So to make 1 10, we need to have 1 2 as well as 1 5 as well. So at least 1 2 and 1 5 needs to be there in the prime factorization of any composite number in order to that composite number to end with 0. This is the conclusion, and this conclusion let us use over here. Now this 4 to the power n can only have 2 in its prime factorization, because you see we can write this as 2 to the power 2n. Now this 2 to the power 2n can further be decomposed and written as 2 times 2 times 2. How many times? We can write it 2n number of times. Correct? Now does it have anywhere 5 in it? No. No 5 is present, right? No 5 is present in the prime factorization of 4 to the power n, or which can be expressed as 2 to the power n. Since there is no 5 present over here, that is why we can conclude that there can be no 10. Since there is no 10, this number can never end with 0. Clear? Let me show you, summarize it once again step by step. Once again, let's revisit this. 4 to the power n can be written as 2 to the power 2n, which can further be written as 2 times 2 times 2 times 2n number of times. Clear? Next, for 4n or any number to be ending in 0, For 4 to the power n, or in other words, any composite number to end in 0, its prime factorization should have at least 1 5 and 1 2 as well. Here 2's are there, but not even 1 5 is there. Since this prime factorization does not have any 5, it only has 2, therefore no, it cannot end in 0. I hope this is clear. This is one direct application of fundamental theorem of arithmetic, and this was asked once in your board exam also. Clear? Let's move ahead. Let's understand now HCF. This fundamental theorem of arithmetic we have understood, which forms a base for the prime factorization. We have seen one application for that as well. Now let's understand HCF and LCM in detail. Till now, you have understood basic concepts from HCF and LCM. Now we'll be learning advanced concept of HCF and LCM. So HCF is nothing but it's short for highest common factor. Example, HCF of 16 and 12 is 4. 16s, how do you find? You have been learning this concept from grade 4, right? You will write 16, the factors of 16 are 1, 2, 4, 8 and 16 itself. The factors, always 1 and the number are always the factors of the given number. Highest factor is the number itself, lowest factor is 1. And number of factors are less than or equal to the number. 12, the factors are 1, 2, 3, 4 and 12. These numbers, the factors are those numbers which can divide this given number 12 or 16 respectively without leaving the remainder, or remainder is 0. Now if you see highest common, what are the common factors? 1 is a common factor, 2 is a common factor, 4 is a common factor. Out of these common factors, the highest common factor is 4. But if there are bigger numbers, it's very difficult for us to use this method to find out the HCF. There's a better method using prime factorization. We'll understand that as well. But the concept here is clear. Highest common factor. Common factors exist for 2 numbers. It can be more than 2 or 3 numbers also, or 4 numbers also you can take. You list down the factors of each and every number. You find out the common factors across all the numbers. Whichever is the highest common factor will be the HCF of all the numbers. Now here, one important extension to this I'll try to tell you. You have understood prime numbers, composite numbers. You would know co-prime numbers also, and co-prime number is something which is directly related to the definition of HCF. Any 2 numbers which have HCF to be 1 are known as co-prime numbers, and this concept you would be using in simplification of fractions also. Yes, co-prime numbers. You may note this point as well. This is very important. Co-prime will have HCF equal to 1. Any 2 numbers which have HCF equal to 1 will be co-prime numbers. Let's move ahead. HCF concept is clear. LCM. LCM is the short for lowest common multiple. LCM of 16 and 12 is 48. HCF of 16 and 12 we got it to be 4. LCM is 48. How to find out LCM? You list down the common multiples and then find out the lowest common multiple. Can anyone type in the chat box what will be the highest common multiple of these 2 numbers? I'll writing down the multiples over here. 16, the multiples are 16, 32, 48 and so on. 12, the multiples are 12, 24, 36, 48 and so on, 60 and so on, 64 and so on. So here if you see, the first common multiple which comes out to in picture is 48. The next common multiple, can anyone type the next common multiple in the chat box? I can see some of you have typed 96 as the next common multiple. Very correct. 96 comes 6 times in 16 table and 8 times in 12 table. And like this, if you go on, there are a lot of multiples, lot of common multiples. You will not be able to find out the highest common multiple. The highest common multiple is undefined for any 2 numbers or more than 2 numbers. It's not defined. It's infinity you can say, but it's not defined. Clear? Lowest common multiple is the first common multiple which occurs, and that is what is defined. That is why we learn LCM. The first thing which repeats in both of them, repeats. Clear? This is a keyword which we'll be using in word problems also. So LCM concept can be applicable in those word problems where anything repeats. 2 things are occurring simultaneously and something is repeating. There you will utilize LCM concept. Anywhere you are arranging the things, there you will utilize the HCF concept. We'll learn that as well. So till here I hope this is clear. However, listing down the multiples like this and finding out the LCM will take a lot of time. There's a better way to do this. I'll tell you that as well. Here one concept more I'd like to tell you. once you find out the first common multiple, the next multiples are very, very easy to find out, because the next multiples are in the table of this lowest common multiple only. If you see 48 is the first common multiple, the next common multiple will be 48 into 2, 96. The third common multiple will be 48 into 3. Fourth common multiple will be 48 into 4, and so on. So once you identify the lowest common multiple, it becomes very easy for you to identify the next set of common multiples. It's just the multiplication table of the lowest common multiple of the numbers. Clear? Let's move ahead and let's understand the better ways to find out the HCF and LCM of two or more numbers. So to find out the HCF, note this down. HCF is equal to prime factorization. We'll be using, let me remind you, based on the fundamental theorem of arithmetic, we'll be using prime factorization to find out HCF and LCM for the numbers. So HCF of the numbers is product of the smallest power of each common prime factor in the numbers. Here the words are highlighted. You need to pay very much attention to these words, because every word I have highlighted is very, very important. Product of smallest power of only common prime factors in the numbers. Note this down. This will be very, very important for us to find out the HCF. LCM we can find by product of the greatest power of each prime factor in the number. Not the common, but every prime factor we need to take into account, and the greatest power of that prime factor we need to take into account, and we need to multiply each and every such number to find out the LCM. This you may note down, take a screenshot. Once done, you can type in the chat box as well. I can see a lot of you are typing. Clear? Let's move ahead then. Clear? Let's see application. One by one, I'll tell you for HCF as well, for LCM as well. So HCF, it's written over here. Product of the smallest power of each common prime factor. Product of the smallest power of each common prime factor in the numbers. Example, 48 and 60, if we want to find out the HCF, I will first write down the prime factorization of 48, which I have written over here. Let me write over here as well. 2 into 2 into 2 into 2 into 3, which is 2 to the power 4 multiplied by 3. Same way, 60, it is 2 times 2 times 3 times 5. I can write it like this: 2 square times 3 times 5. Now, if I want to find out the HCF, I need to highlight only the common factors first, common prime factors. Let's highlight the common prime factors. Let me use a different color. Let's use a green color. So this 2 is common, this 2 is common, this 3 is common, this 3 is common. Now among 5 is not common, so I have not highlighted 5. Now among these 2 and 3, which is the lowest power, which is the smallest power? We need to find out which is the smallest power. Only the common factors we have highlighted. Next step is to find out the smallest power among these common factors. So smallest power of 2 in 48 and 60's prime factorization is 2 square. So I'll write down 2 square. That will form one element in my HCF. Next, so this I have selected. This is the smallest power. Smallest power of 3 is 1 only. Both places it's 1. So 1, 3 I have to select. Any one you can select. I'll select 1, 3. So 2 square into 3, when you solve this, you will get the answer to be 12. 4 into 3, 12. 12, it's the HCF of these two numbers. The same thing, same technique we can use for 3 or more than 3 numbers as well. Clear? I hope this concept is clear. This is what the definition also says. Product of the smallest power of each common prime factor in the numbers. Let's move ahead. Let's understand in the same way LCM also. LCM is the product of the greatest power of each prime factor in the numbers. Every prime factor we need to consider. Same way what we did for 48 and 60, right? Well, I'll write it once again. 48's prime factorization is 2 to the power 4 into 3. 60, it is 2 square into 3 into 5. Now here each and every prime factor we need to consider, every unique prime factor we need to consider, every prime factor's greatest power we need to highlight. So let's highlight the greatest power. Let me use this purple color over here. Greatest power of 2 is in 48, which is 2 to the power 4. Greatest power of 3, any one you can take, it's 1 only, I'll take this. For 5, it's 1, any one, only 1, okay. Now let's multiply these powers or these prime factors and get our answer for the LCM. So LCM will be 2 to the power 4 multiplied by 3 multiplied by 5. The only difference over here is not simply greatest and smallest. In case of HCF, you will be looking common factors, that only you will select the highest power. In LCM, you will be looking each and every prime factor, and from that you will select the highest one. Clear? And only one you have to select, not both. Okay. So this, when you solve, you will get 16 times 48 times 5, you will get the answer to be 240. I hope this is clear. So this much concept you have done. Let's quickly solve some problems. Now, before we get into the problems, one more important relation I want to tell you, highlight to each and every one of you. We have seen 48's prime factorization, 2 to the power 4 into 3, this, it's written over here once again. HCF of 48 and 60 is 2 to the power 2 into 3. LCM of 48 and 60 is 2 to the power 4 into 3 into 5. If I multiply HCF and LCM of these two numbers, 48 and 60, what will I get? I'll get 2 square into 3, which is the HCF, multiplied by 2 to the power 4 into 3 into 5, which is the LCM. Now, with some little bit rearrangement, if I rearrange, this 2 square into 3 and into 5 is nothing but the prime factorization of 60. This 2 to the power 4 into 3 is nothing but it is the prime factorization of 48. With this little rearrangement, we come to the conclusion that the product of HCF and LCM of any two numbers is equal to the product of the two numbers itself. This is very, very important conclusion. You may note this down. HCF into LCM of any two numbers is equal to the product of the two numbers. And this is only and only valid for two numbers. Only valid for two numbers. If there are three numbers, we cannot say that HCF into LCM of the three numbers is equal to first number into second number into third number. For that, separate relation is there. This is only and only valid for two numbers. Clear? Let's move ahead. Let's see one question over here. HCF of 96 and 404 we need to find out using prime factorization method, and then we need to find out LCM also. Let's first find out HCF and then let's use the relation between HCF and LCM to find out the LCM as well. So find out the HCF. The first thing is I need to prime factorize 96. 2 times 2 times 2 times 2. This will be 2 2s are 4, 2s are 8, 2s are 16 into 2, 32 into 3. 96. This I can write it in compressed form 1, 2, 3, 4, 5, 5 2s 2 to the power 5 into 3. 96 is 2 to the power 5 into 3. 404 in the same way if I write 4 into 101. 101 is a prime number. So I can write it as 2 square into 101. Now HCF of these two numbers is the smallest power of the common factors, the smallest power of the common factors. The common factors are 2 to the power 5 and 2 square. 2 square is the smallest power. HCF is simply 2 square, which is 4. HCF comes out to be 4. What is the relation between HCF and LCM of two numbers? HCF multiplied by LCM is equal to product of the two numbers. Let's use that and let's find out what is LCM for this. Let me do it over here itself. Let's erase this and let's do it here itself. Okay, just a second. So we have got the HCF, to be 4. We need to find out the LCM. HCF into LCM multiplied by LCM is equal to the product of the two numbers 96 into 404. HCF is 4, LCM we need to find out is equal to 96 multiplied by 404. LCM will come out to be 96 multiplied by 404 upon 4. 4 1 times 0 times 1. Now here a lot of students would multiply 96 into 101 one by one using the traditional method. But if you have been following the Sisyaclass YouTube channel, or if you would have registered for our 1 week booster course, right, those students, you will give the answers very fast in the chat box. I can see a few of you are typing in the chat box 9696 is the answer. Very good. Because any 2-digit number you want to multiply with 101, you just need to repeat the 2 digits. As simple as that. These things we have taught in our app as well as our YouTube channel. You can go and check in the videos yourselves. Let's move ahead. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. So same method, not 2 numbers, 3 numbers let's do. 6, the prime factorization is 2 into 3. 72, it's 12 into 6, which is 2 into 2, 4, into 2, 8, 8 into 3, 24, 24 into, just saying, 2 to the 4th into 3, 72. Clear? 2 to the 4 to the 8, 3 is 24 into 3, 72. Next 120, 12 into 10, which is 2 times 2, 2 to the 4, 3 are 12, 12 5s are 60, one more 2 will come into 2. So let me write it in this way. Let's write this in compressed form of for each and everything, each and every number. So this will be 2 to the power 3 into 3 square. Eight into 9. This will become 2 to the power 3, 8 into 3, 24 into 5. So we have the prime factorization for each and every number over here now. Now we need to find out the HCF first. To find out the HCF, we will only select the common factors. The common factors are 2, 2 cube and 2 cube. The smallest common factor is 2. So 2 I will select. 3, 3 square and 3 is common, and the smallest power of 3 is 1. I will select 3 to the power 1. So the HCF is 2 into 3, 6. That's it. 2 into 3, 6. LCM. Select the highest power of each and every factor, irrespective of whether it is present in each and every number. No, every number, every prime factor you need to select. So 2, the highest power is 2 cube. So let's select 2 cube. 3 is there. 3, the highest power is 3 square. Let's select 3 square. 5, highest is 5 itself, 5. So 2 cube, 8. 8 multiplied by 9 multiplied by 5. 72 into 5, which is 360. 360 is the LCM. Clear? So whether it is 2 numbers or more than 2 numbers, we can easily find out HCF and LCM just by using that method. HCF is the product of the smallest powers of common factors, common prime factors. LCM is the product of greatest power of each and every prime factor in all the numbers. Clear? So we use the technique to find out HCF and LCM very fast. Let's move ahead. Given that HCF of 306 and 657 is 9, find the LCM. So HCF and LCM have a relation, we know very clearly. HCF multiplied by LCM of any 2 numbers is equal to the product of 2 numbers. 657. Correct. So HCF is given to us 9 multiplied by LCM is equal to 306 multiplied by 657. LCM will come out to be 306 multiplied by 657 upon 9. This will go 9 3 times, 9 4 times. So 34 into 657 you have to do. You can multiply on the side. 34 into 657, 4 7 times 28, 2 carried, 2 carried, 26, 7 1 carried, 1 9. When you add 8 3 3 2 2 2 2 double 3 8 double 2 double 3 8, this is the answer. I hope this is clear. So if you know how to find out, if you know the relation, you can easily find out. No need to prime factorize 306 and 657 again. HCF is already given. Just divide the product by the HCF, you will get the LCM. Simple. Clear? Any doubts still here? Any doubts? Anyone? Please let me know in the chat box. Clear? Let's move ahead. So we have understood this. I hope this is clear. Now this is the final question now. This is very important question. This word problem caters the application of HCF and LCM. So I have chosen this word problem. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Suppose this is the starting point. They go round and round. Both of them start at the same point. Sonia takes 18 minutes. Ravi takes 12 minutes. So obviously, first round Sonia will complete later, Ravi will complete very fast. So like this, first they started together. If they continued going round and round and round, at what time will they meet again? So this you can easily find out by using the repetition, right? Repetition of this minutes. If I write down 18, if I write down 12, first 18th minute, 12th minute. Now 18 minutes, after 18 minutes, not at the same time. 18 minutes, 12 minutes, they started, they are at the same time. Then after 18 minutes, again when Sonia will come at the same point, 36th minute. Ravi will come at the same point, 24th minute. Then after 36th minute, it will be 54th minute. Then this will be 36th minute. So 36 is common over here, both. Correct. This is the concept. Now, when you understand that repeating certain things are repeating again and again. Suppose two bells start ringing at the same time. One bell rings at 2 minutes, the other bell rings at every 3 minutes. So first 2 minutes, after the first 2 minutes, both the bells will ring. After the first 3 minutes, one bell will ring. The same if it continues. On the 6th minute, both the bells will ring together. The same concept is over here. As I told you at the start as well, whenever certain things are repeating, always be careful that this problem is related to LCM. Do not use the concept of HCF and do it wrong. So let's apply the concept of LCM. Once you understand LCM is to be used, it's very easy. We have found out the answer. Let's understand step by step. Sonia, time taken is 18 minutes. Ravi, time taken is 12 minutes. Time at which they meet again is the lowest common multiple of their times taken, 18 and 12, which is 36. So 36 minutes it will take for them to meet at the same point again. You can easily find out. Let me write this down, the prime factorizations. 2 times 3, 6 times 3, 18, 2 times 2, 4 times 3, 12. So 2 highest power I'll take, 3 highest power will take. 2 into 2 into 3 into 3, this will be the LCM. 2 square into 3 square, which comes out to be 36. 4 into 9, 36. Clear? So in this way, you have to do it, and the answer is 36 minutes. This is a very good question. Now, last, I told you there will be a special reveal, and this is the special reveal. We'll be starting with the ultimate bridge session for all those students who are going from grade 9 to grade 10. This series will be very, very helpful, let me tell you. And this we are starting from 7th of October. So please stay tuned to our channel. Please subscribe, please like, share with your friends as well. Those students who are going from grade 9 to grade 10, it will be very, very useful for you all. And this, let me announce this special reveal as well. This is not only in one language, this is in 3 languages. So your Telugu friends, your Hindi friends, those who are on other multiple languages, those who are studying in international schools, they speak only English, right? You would have such friends as well. So for all the 3 languages, we are doing it simultaneously, starting from 7th October. So please stay tuned. And last but not the least, I told you, booster course is going on our Sisyaclass app as well. And you can download by scanning this link, and the link is also provided in the description. Please scan this link or go through the link in the description. Go through our app, download it, take its benefits. A lot of benefits are there. The major benefit is the booster course which we are running. Okay. So that's it. Please like, share and subscribe. Okay.